different challenges based on the physical properties of the Moon and Mars, the differences in their atmospheres, the differences in power generation options there at the two places, and landing in the atmosphere, and the difference in communication from those places. But I think that from the point of view of practical challenges, how do we get there? We can start by talking about the basics that would be necessary in any off-planet colony, which, for purposes of this discussion, will include the space station. So, what do human beings need? Water, food, sunlight. You really don't do very well if you go that long without sunlight. Water, food, pressurized air, whether it's in a spacecraft or a spacesuit, or even in a scuba diving environment where you have to very carefully regulate the pressure inside your body. And these things that are all pretty hard to get off of the Earth. I mean, we've evolved here, and it works pretty well for us. And really, when you go into space, you're basically challenging the universe to kill you in any number of horrible ways. But we still do it because we are dreamers and explorers, and we're crazy. So we do it. Now, the space station, it's just a few hundred miles away, and about half a dozen people can live up there. And most of their time is spent keeping it working. So I think that's a really important detail that is not recognized often enough. Now let's talk about the space station itself. There's huge solar panels that, if we spin this way, we will see are roughly pointed towards the sun, for obvious reasons. And there is a habitat module, which is basically right here, I think. There's the work module. I'm sorry, the habitat is somewhere around here. There's the work module, labs, and importantly, there is a spacecraft docked to go home. At least one. There's a second dock over here. There's a robot arm to move things around on the outside. And I forget which one of these has all the supplies, but it takes a decent amount of space for the supplies. And there's a communication system. You'll notice that it communicates up. These satellite dishes are pointing away from the Earth because the space station communicates with an orbiting communications network that then relays to the ground. There's probably direct-to-ground transmitter somewhere, but you can see that it's a pretty complicated setup, and it really takes 90% or something like that of the crew's time to keep it working, which is a big problem if you want to think about a self-sustaining colony like a city or a town on another planet. And the space station, of course, is entirely dependent on shipments from Earth of everything, of all consumables, and plenty of stuff that's not consumable, like spare parts and electronics and things like that. So, and to put it in context, it's probably the most complicated thing ever built, and it's among the most expensive things ever built. Something like $150 billion if you add up the cost over the 20 years it's been taking. Now, that's certainly real money, but I think it's important to keep in mind that's government money, which of course is in theory tax revenue, but point being, it's sort of on the scale of government projects that are not necessarily designed to be self-sustaining and never really were, and so you almost have to ask yourself at that scale, is that even a drawback? I think most people would argue that the main reason for building the space station was to give former Soviet scientists something to do other than rejoin the no longer Soviet countries. Likewise with various sensitive places around the world. And so this was following the fall of the Soviet Union. And if you think of it that way, it's been of extremely high value, such as it may have limited the spread of various sensitive technologies around the world. So there's a strange sort of calculus that starts to happen when you get something that's beyond a certain level of expense, something that's so absurdly expensive that it is an opportunity cost for other things that maybe you don't want, like a diaspora of former Soviet scientists going somewhere else. So maybe that will turn out to be the right model um, for colonies as well. That if governments of the world are putting their resources into that sort of thing, they're not using them to fight with each other. So who knows? But anyway, let's get back to the physical and biological stuff. So space station requires constant resupply, constant maintenance, and is really not a sustainable system. We can talk further philosophically another time maybe, but enough about the space station. Going to the moon is at least an order of magnitude more difficult. Let's see if I can find them. It might not be over here. At least an order of magnitude more difficult than where the space station is in low Earth orbit. But in a sense, it is so far away that it would force certain technologies that you can almost get by without in the space station. For example, the space station is close enough to Earth that you can bring water there, and food there. And it doesn't have to be self-sustainable because it's so close to the Earth. Now, if this is ever pursued in a serious way on the moon, there will be very interesting conversations about what level of Earth support are we going to have, and and what things are we not going to rely on at all. And if you think that's unfair, or that somehow defeats the purity of a moon colony, I'd ask you to keep in mind that, with few exceptions, there are not many places on Earth still that are totally self-sustaining without relying on imports from other parts of the Earth. That's not to say you couldn't completely, wall off every country and everyone would be self-sustaining. There'd be sort of an optimization process as, let's say, Lithuania discovers what its arable land can support and so on. But my only point is that it's somewhat more complicated than it might sound to, rather it's not as simple as just a colony that's functioning by itself, because that wouldn't make any sense either, except in some kind of science fiction dystopia where it's impossible to communicate with the Earth or something like that. So the point is, there'll be conversations about what are we going to bring and what are we going to make on the moon. And I think some of the things you can make on the moon pretty reliably are power. If you can generate solar power pretty easily, and because of the lack of an atmosphere, it is slightly more practical, at least than Mars, to land very large things like solar panels or deployable systems or something like that. There is a decent amount of water distributed throughout the moon, whether it's in the poles or the craters, which are places you can actually go to get water that you can use, in principle, melted and possibly separated. So with that, you can also make breathable air. So it would seem reasonable to me that, at least at a high level, you would have some kind of emergency system where you'd have a stockpile of breathable air and water. Perhaps that would be the first thing you would generate when you got there, but that you could probably have a sustainable local system generating water and air. How you would get that through a NASA risk panel would be a very interesting process. But in principle, you could do that. Food, there's really not a lot of the basic elements of food. Elements of food at the moon. Hard to imagine how you could make it there until you were able to build some kind of totally self-contained biodome or greenhouse or something like that. And even still, you'd need to bring a lot of stuff with you, like dirt and seeds, at least until you had a renewable source of seeds there from things that grew. But seeds aren't that heavy, so maybe you could have them shipped from the Earth. So communications with the Earth also are pretty simple, and because you don't have much of a delay, that's probably not a major challenge. And one thing you'd have to do, you'd have to have some very, very interesting materials, advances in material science, because one of the things that was found on the moon is that the dust is so fine that when you blast off, the cloud of dust is extremely dangerous, not in its traumatic or kinetic impact, but rather in its fine, sharp impact. It scrapes things. It abrades things, and it gets into surfaces and cracks on surfaces that on Earth we don't really have to worry about. In fact, when the people who went to the moon got back on their spaceship or their landers for the evening or whatever, to get back into the lander, they had to spend a lot of time actually cleaning this dust out of their spacesuits, and it got caked all over the inside of the spacecraft, and there was a concern that perhaps it had some conductive properties that could cause a problem. And anyways, so the dust is an interesting problem, and not something we face here. But so those are some of the very high level challenges on the moon. Now, going to Mars. Well, we haven't even talked about getting stuff to the moon and back. We already know how to get stuff to the moon in a week if you want to build a 30-story rocket. Actually, if it didn't have to come back, you probably could get a lot more there with a 30-story rocket like the Saturn V, or you could build something else that perhaps wouldn't have to be as big if you didn't need it to come back. So maybe you would do something like have the rocket land vertically and have that be a structure that you use for something. I don't know. It would be fun to be part of this. Project, that's for sure. So, getting stuff and landing it on the moon is, I would say, a solved problem, at the risk of stating that anything in space is a solved problem. It can be improved, but we know how to do it, and we've done it. We no longer miss the moon or crash things into the moon accidentally like we did in the 50s and 60s, early 60s. So that's good. I am... okay, so I think, Buck, you can hear me because you're typing to me, which is good. So, yeah, so, if NASA was allowed to function in a responsible way, we would have the kind of prototype things that Buck is mentioning, kind of in a pipeline, in a longer-term pipeline of showing capabilities and testing things out on the moon. And in fact, during the Constellation program, there were a number of very interesting technologies that were developed that I had the privilege to see and talk with the inventors of at JPL, that are in some kind of limbo or worse because of the lack of a plan now. For example, there was a very interesting 6-legged rover that can sort of walk and roll, and would be extremely useful on the moon for moving things around and stuff like that. So it's a real shame when people are excited and build something, work on it for years, and then it goes nowhere. So we'll try not to go down that road because that's just depressing. But again, this is sort of the higher level what the different challenges would be. So let's go over to Mars. We talked a lot about the moon. I mean, I think the short version is the moon is easier than Mars, but you really have to ask why you're going and what your goals are when you're there, other than not dying, which presumably is one of your goals. So let's actually consider a third option to colonizing the moon or Mars, and look at the moons of Mars. And they are very interesting objects and probably captured asteroids. Their orbits are decaying, so in 10 million years or something like that, whichever one is closer, I can't remember at the moment, is going to hit the planet Mars. It'd be pretty cool to see that if anyone's still there, or anyone's around there. Less cool to see it from the surface, but cool to see it from anywhere but the surface. And so they're really small objects, which makes them great gravitationally, because you can get to them pretty easily and leave them pretty easily. I think any kind of sustained Mars presence is going to require some kind of way station or depot or something on these objects to create a middle ground between the surface and wider orbits and the Earth. And Buck says Homo sapiens will be long gone. I assume you're meaning in 10 million years. I think by then we'll either be gone for good or we'll be distributed around the solar system or farther. I'm hoping for the latter. I almost said we'll see, but none of us will see. So I'm going to just be optimistic about that. So anyway, back to Mars. So Mars has very different challenges than the Moon. Oh, well, sure. I mean, you could have, if you have enough people in another place long enough, they'll start to evolve. But, uh, well, we could talk about this for hours, I'm sure. But I think that the first bunch of humans that go somewhere are going to have to bring enough technology with them because they're still going to be normal Earth humans. I suppose over time, if you were to expose people to scenarios that humans couldn't survive in, you could start to have something like evolution happening, but that would be I think, require a much larger starting population, not just for the genetic diversity, but also because, if a giraffe is born with an unusually long neck, it can reach a higher plant on Earth. That's pretty benign. That's a pretty benign environment in which that change is happening. If you're on Mars and you're talking about, let's say, people evolving to be taller or having different oxygenation needs, you're not going to find that out without going out there and dying. So I'm not sure that evolution would make the changes fast enough. But the point is certainly well taken that will be a factor in life no matter where humans go, and what role it could play in adapting people to a different planetary environment is another question. Yes, so perchlorate, the stuff in the soil on Mars that just chews up organic molecules. As far as we know, on the surface, not that deep in the surface. And again, if we're not talking about, well, I'm at least not talking about people walking around on the surface with no protection, but certainly seems like perchlorate, as widespread as it is, would get into habitats eventually and into equipment, and who knows, maybe there should have been a scene in The Martian where, what's his name, where Matt Damon finds half his crop has been killed by perchlorate. So, yeah, so that's a good point, that adapting to that would be positive adaptation. But let's take a step back a little farther and talk about the challenges on colonizing Mars that we don't have on the Moon. One is the distance. Excuse me. For now, it takes about 9 months to get to Mars, and you can only leave every 2 years. And that's because of the way the planets move, and actually we can show that. Oops. Oh, I hope that doesn't crash anything. I just full screened this thing, and what I meant to do was click this button. This button. Where we are going to watch the Earth and Mars orbit the Sun. So you can ignore the rest of this stuff. Here's the Earth. Here's Mars. This is not the time you want to go to Mars, because it's all the way on the other side of the Sun. That's really far. But if we speed up, oh man, my poor computer. Okay, we speed things up. Earth is coming around. Because Earth is closer to the Sun, it was faster. So eventually you see, now we're about a quarter of the way around, and now is when you want to leave the Earth. Because as you get farther and farther away from the Earth, you're still being pulled on by the Earth, and then here is around the time you intersect with Mars orbit. So as you can see here, this is, what date is this? August 9th, 2018. So this is around the time when Earth and Mars are closest, and Mars actually looks bigger in the sky because it's suddenly only a third as far away from the Earth as it was when we started. So getting to Mars is much more challenging. You can only leave the Earth for Mars, at least in the ways we've done it so far, every 18 months. And it's much farther. You need a lot more supplies to just get there and live, and of course we've never done that. And once you get there, you have a very different and very challenging environment, which we won't look at it directly because this program doesn't have that stuff, but we can talk about it. So as I mentioned into the void earlier when my microphone wasn't working, the Mars atmosphere is only 1% as thick as the Earth's, which is really annoying because if there's no atmosphere, you'll have it like the Moon, where it's relatively much simpler to land stuff because you don't have to worry about the atmosphere. And on the Earth, you have a very thick atmosphere, at least you have the normal atmosphere that we're used to, which we can use to slow down significantly. On Mars, you have an atmosphere that's just thick enough that you can't ignore it, but not thick enough that you can use it for slowing down, at least not to the extent we would like to. So, for that reason, you see landing systems on Mars, like my previous stream, using very complicated systems with multiple stages, like parachutes and retro rockets and balloons in some cases. So that's just Mars. So Mars is hard, as we say. So once you've landed on Mars, you have a very different environment than you have on Earth. You know the Martian atmosphere is actually kind of Earth-like. It has the same elements, the same major chemicals as on the Earth, but in a very different ratio. So you do have oxygen and carbon dioxide and nitrogen largely making up Mars' atmosphere, but not in anything like the ratio on Earth, whatever that is. I can't remember at the moment, but and of course it's a much lower pressure, so you couldn't breathe it anyway. Plus, as Buck points out, there's a large amount of a molecule in the dirt called perchlorate, which really likes to chew up and destroy organic molecules, which is one of the reasons why, at least as the last time I checked the papers from MSL, which is why we haven't seen organics, I should say, what's the word? Intact organic molecules in the surface. I might be oversimplifying that or getting it just plain wrong. I can't remember at the moment. But the point is, it's something in the environment that's very different than what we're used to on Earth. So once you've landed on Mars, you're much farther from the sun, so your solar panel output is a lot less. And you had to get the solar panels through the atmosphere, which is a very different challenge than on the moon. So solar power is very difficult, because to get enough equipment there to make it useful is much farther away and much harder to land. You can make, if you have power, you can make you can make breathable air the same way you would on the moon, assuming you have a structure to hold it in at a pressure that humans can breathe. Water, likewise, there's a lot of water on Mars. You can see it there on the pole, and there's actually, I don't think there are quite as many ice-filled craters on Mars, but there's actually enough vapor in the atmosphere and near the ground that at certain times of the year there's actually flowing liquid water. We have photos of it. Now, small amounts, and I doubt NASA would ever let anyone get anywhere near it, but in principle it's there. So you'd most likely have some kind of, maybe your colony would be closer to the pole or to some other major ice or water deposit that I can't remember at the moment, or it hasn't been discovered yet. So you have some of that, so that's kind of better than on the moon. You at least, well, no, on the moon you have ice, you have lots more ice in craters, so maybe call it a wash, except that on Mars it's much harder to get to. So, wow, we have 6 people. That's pretty exciting. We'd love it if anyone else would say who they are, because I only see a number. So, on Mars, you probably want some kind of nuclear power system, fission. Well, that's the one we've got. So, we really don't. Oh, hi, Fifi. I'm really happy to see. Well, I'm not happy that there are flat earthers, but of course there are, and welcome. So, thank you for joining. Flat earthers. Wow, they kind of stopped me in my tracks there, because there's a lot I could say about flat earthers, and really the kind of fundamental psychology that goes into believing that kind of stuff, which might be a subject for another video. But anyway, back to Mars. So food. I think it's probably not that controversial to say that the mineral and organic content of the soil on Mars is slightly more suitable than on the moon, but that's not saying much. More likely you would need probably to mix something that you brought with you with the soil, or bring it with you. Buck has a friend who's a moon hoaxer. Um, yeah, we could talk about it, but what I find, to the extent that moon landing deniers have a kind of coherent viewpoint on it, which they don't all, the perspective I've seen a lot is they can't imagine how it could be done, so therefore it couldn't have been done. And I find that kind of thinking very limiting. There's plenty of things I don't understand how they work, but that doesn't mean I don't. That doesn't logically lead to the conclusion that no one else can. So, again, maybe that would be an interesting topic for a video about the psychology of people who refuse, who reject scientific inquiry because they can't do it or they don't want to do it. Anyway, back to Mars. So, power, probably nuclear fission, which would mean moving a nuclear fission system from the Earth to Mars, probably with your nuclear fuel along with it, which hopefully will be an option someday, because there's really not a lot of other ways to get power. And yeah, so that's really what your options are there, and that would be very heavy. Now the nice thing about actually these power systems is that you don't have your cooling of them, keeping them cool, would be easier on the Moon and Mars. Well, on parts of the Moon, parts of the time, and certainly on Mars than on Earth, because the outside atmosphere is much colder. Plutonium batteries. So I think it's unlikely you're going to use radioisotope power generation for a colony, because you would need so much plutonium that it would be easier to actually build a nuclear fission system. So deep space spacecraft use basically plutonium batteries that use the radioactive decay of plutonium converted to electricity to power themselves for decades. But that power there's really not a lot of power, less than in most cases, less than you would use to even power a desktop computer. So, and that's using a pretty large amount of plutonium, considering how little of it there is, or rather of that isotope of plutonium. So it would actually be easier to invent and build a giant fission power system that you could fly to Mars than it would be to get enough plutonium to Mars to use RTGs, in my opinion. So, communication. So, we've seen some photos, and I don't want to screw up my stream by adding another window to it to show the photo, but you've seen photos of Earth in the sky on Mars. So, maybe I can find the Earth here if I look closer to the sun, maybe we get a look at the Earth on this program. Now, the short version is there's a 6 or 7, there's the Earth. So, the Earth is very small when you're on Mars, and it's very far away. And it takes, I think it's like 12 minutes for a signal, a communication signal to get back, to go back and forth. And that's long. It's manageable, but it's still long. But it would definitely mean that any kind of emergency would have at least a 10-minute delay before anyone could help, and that would just be to hear about the fact that there's a problem in the first place. So the Mars colonists would definitely be on their own to a large extent, and that would raise a lot of interesting challenges. Again, to communicate, you need various types of equipment that you have to bring there. That's not as hard as bringing a giant solar panel, but it's still a challenge. Now, so we've talked about some of the challenges on both of these places, the Moon and Mars, and I'm going to have to go shortly, so I kind of want to wrap it up. I think the bigger question we have to ask is, why would we do this? As much as for me, the answer is because it's there and because we can. That's a good enough answer for me. But before the world, or some subset of the world, is going to commit to this kind of thing, we really need to have a good reason why. I kind of like to dream that the world will come together and explore space for the sake of exploring space. I think we've seen that things like the space station can be very valuable projects from the point of view of creating an opportunity cost that prevents people from doing other things that are less desirable. So if your option is $500 billion spent on some horrible tragedy, or $500 billion spent on a space station that keeps the people busy so they can't go commit that horrible tragedy. Maybe that's a net gain. I mean, like I said earlier in the stream, that kind of thinking becomes inevitable once you're above a certain scale. Uh, so, so the bigger question is, again, why would we do this? There's a lot of exploratory reasons that we would do that, but I think ultimately it's that reason that's going to drive which planet we go, which place we go to first, the Moon or Mars, and really dictate the way it's done. Because in the same way we went to the Moon the first time, there was no attempt at sustainability, and in fact, a third of the rockets were not a third of them. Three of the giant rockets were just discarded at the end of before the end of the initial program, because the job had been done, which was to beat the Soviets. So that's sort of my conclusion. I'm going to answer these questions, but that's my conclusion, that in the same way that going to the Moon in the 60s was so incredibly difficult that it had to serve a symbolic purpose more than a practical one, and I think it did that, and to the benefit of most of the world. I think that proper planetary colonization is going to have the same. It's going to have the same thinking behind it. So, if we're going to colonize Mars, do you think people should go there, follow the laws and society rules on Earth, or create their own new set of rules? Great question. I really like the philosophical thinking there. I think that on a practical level, the people who go to Mars first are going to be spending 99% of their time staying alive. And it'll be a long time before there's anything like the freedom from survival, really, that it would take to create something like a society as opposed to a series of rules that keep you alive. And it's hard to imagine a scenario where you won't be far from survival, even if you have a little village or whatever. But ultimately, I think that there will be an interesting kind of colony/sponsor relationship between any kind of colony and people on Earth, in the same way that maybe this is a strained example that the American colonies had to find their own relationship with England. With that, though, I'm going to go, and thank you very much for joining me, and I'll see you on the next one.